Hi ladies, in this video I'm going to go through the trig ratios. So basically we use the relationship between the three sides to work out, and the angles within a triangle to work out what an unknown is. So it's a bit different to Pythagoras' theorem where we're only dealing with sides. With the trig ratios we also have the angle. So if you've got two bits of information you can find a third. Now your trig ratios, the labeling of the triangle is always important. So I'm going to do that over here. So we're still dealing with right angle triangles. So Pythagoras, we deal with right angle triangles. And we label the hypotenuse C when we're using Pythagoras' theorem. But when we're using the trig ratios, we just call it the hypotenuse, which it is anyway. But hypotenuse is always your longest side. So I'm just going to use the letter H to represent hypotenuse. Now, when we're dealing with trig ratios, as I said before, we're always got an angle. Okay, so it's a bit different to Pythagoras because we don't deal with angles with Pythagoras, but in trig ratios we do. Now, the side alongside your angle, so if you think about the letter A and the word adjacent, they both the letter A. Letter A stands for angle and adjacent. Sorry, I'm a little bit tongue twisted. Okay, so A for angle, A for adjacent. So that's that side alongside your angle. And the side opposite your angle we label as O. Now this sign here that I put in for the angle is theta, and it's just a Greek letter that we use to represent an angle. So often you'll see in maths, especially if you go on to do VCE maths or university maths, you'll see Greek letters used quite a bit. So we don't use normal letters, English letters, we use Greek letters as well. So that's what that is, theta. Now, to remember what ratio to use, because these ratios are just relationships between the sides, okay? Now, if you're looking at this first triangle, if you've got the hypotenuse side, so if you're being given a value for H and you're given a value of O, or you have to find one of them and you've been given the angle, we use sine. Okay, now you've probably heard SOHCAHTOA. So just helps us remember that sine is used for opposite and hypotenuse. Okay, so when you know the opposite side and the hypotenuse, or one of them and an angle, we use sine. Now, if you have the adjacent side and the hypotenuse, or one of them and an angle, we use cos. So to remember that, we use acronym CA. And then lastly, we've got TOA. So that's for tan. So tan theta equals opposite over adjacent. So these, when you think about it, a ratio is just a relationship between two numbers, and that's why it's called a ratio. So the relationship between the opposite and the hypotenuse is equal to sine theta. The relationship between adjacent and hypotenuse is equal to cos theta, and opposite and adjacent tan theta. So as you can see here, sine theta equals opposite over hypotenuse, cos theta adjacent over hypotenuse, and tan theta opposite over adjacent. So to remember them, we always say SOHCAHTOA. Now, the sine, the cos, and the tan are also buttons on your calculator. So use it normally in trig. Some questions we can do without a calculator, but doing what we're going to be doing now, we just do on the calculator. So you need to be familiar with the buttons sine, cos, and tan. So I don't actually have a little green scientific calculator here, but I'll just show you on a graphics calculator, a CAS calculator. A graphics calculator is what I used when I was in high school a very long time ago. Okay, so sine, cos, tan. And you'll notice these buttons below them, and we'll be using them in a second. Now, if you've got a little green calculator, you'll easily find those buttons. And usually the inverse sine, inverse cos, inverse tan, you'd probably have to press shift sine, shift cos, shift tan. Okay. Now let's look at question 1. In each right angle triangle below, we've got to decide whether we're using sine, cos, or tan. Now you're probably wondering why I'm saying sine and not sin. It's because the full sine, cos, and tan are actually abbreviations of sine, cosine, and the tangent. Okay, so that's why I say sine, not sin. So you should be saying sine as well. So once we've decided whether we use sine, cos, or tan, we then find the unknown side x, corrected 2 decimal places. Now, when I'm doing anything in trig, I always label my sides first. So looking at A, longer side is always your hypotenuse. The side opposite your angle is your opposite, so O, and there's theta. So I'm going to put theta there. Now I'm going to do B and C, and then I'll put the answer down below. So B, hypotenuse, side alongside your angle is adjacent, so A, and there's theta. You get your angle. Hypotenuse we don't have this time, so I'm not going to label it. You can if you want to, but you don't need to. Side opposite your angle is O, and the side adjacent your angle is A, and that's theta there. Okay, so if we're going to do question A, now it's a bit hard because I can't keep scrolling. Actually, I will do that. Now, even though I've labeled the triangle, something I still do is, and encourage students to do, is just write HOA, theta, hypotenuse opposite adjacent theta, and then list what you have. So we've got hypotenuse is 31, opposite is 0, or not 0, x, and theta is 42. So 31x 42. Now there was nothing there for the opposite side, so I would usually just cross it out. It means I don't need to use that opposite. So I'm dealing with just the adjacent and the hypotenuse and theta. So this is where your trig ratios come in. If I'm just working with opposite and, oh gosh, sorry. I knew I'd make a mistake. So I try to remember things. Let's quickly scroll back. Sorry, hopefully you realized I did that incorrectly. It's the adjacent side we don't want. So we're dealing with the opposite and the hypotenuse. Opposite and hypotenuse, just need to check that. Okay, so the trig ratio we're going to be using is sine because we're dealing with the opposite and the hypotenuse. Now, good habit to get into whenever you're working with formulas is always write them down. Just kind of sticks in your head. So theta is 42. Now, put in the brackets 42, opposite is x, hypotenuse is 31. Okay, so I know that I'm using sine, the sine ratio. The second part of the question is find the unknown side. So here I've got an equation. Okay, sine 42 equals x over 31. So if this was any algebraic equation, I just need to get x by itself. Doesn't matter that I've got the sign here, just treat it like a number because it is a number. Okay, if you put in sine 42 into your calculator, you get a number. So we just want to get x by itself. So because 31 is in the denominator, I multiply both sides by 31. So that cancels out and I'm left with, and I always like to write my prenumeral on the left-hand side. So x equals 31 times sine 42. And then I just put that into the calculator. Now there's one thing you need to check. Just make sure your calculator is in degree mode. So I can see, but you can't see my calculator. Just scroll over. Up here it does say degree. So if you're using a CAS calculator, you can check there. Now if your calculator is a little green scientific one, it should still stay at the top, whether it's in degree, or it might say RAD for radian. So you need to switch that. So if it's in radian mode, there's probably a shift button that you can press. If there's a button that says DRG, that's your button that you need to switch from degrees to radian. And I'm sorry, I don't have an emulator to show you how to do that. Okay, so let's finish this question. So it's 31 sine 42. So it's just 31 times sine 42. And we're doing it to 2 decimal places, so 20.74. All right, so let's have a look at question B. Hopefully this time I copy it down correctly. All right, so hypotenuse, opposite, adjacent, theta. Let's go back up to B. So hypotenuse is 26, adjacent is x, and theta is 37. So this time we don't want the opposite side, so I'll cross that out. So I'm working with the adjacent side and the hypotenuse side. So I know it's cos, but if you're a bit unsure, just go up to this diagram here. We know the adjacent and the hypotenuse side, so we're using cos theta. Now let's just go and substitute everything in. So your adjacent side is x over hypotenuse, which is 26. All right, so it's now an algebraic equation, so we just need to solve for x. Because 26 is on the denominator, we just multiply both sides by 26. So that cancels, and then we've got x equals 26 cos. I didn't substitute the 37 in there, but it should be a 37 there. Let's just put it in now. Okay, so then we put it into the calculator, 26 cos 37, 26 times cos 37, and 2 decimal places we get 20.76. All right, let's have a look at C, because I know C is an example of tan, so let's write HOA theta. All right, so I'll scroll up. Okay, so no hypotenuse this time, so we've just got O is labelled as x, adjacent is 58, and theta is 29. So x 58, 29. All right, so we're using tan. If you're unsure, remember SOHCAHTOA, or you can go up and look at the diagram above. Okay, so tan 29, opposite is x, and adjacent is 58. So we're solving for x, so multiply both sides by 58. So that goes, and we're left with x equals 58 tan 29. And we just put that into the calculator. So 32 and 2 decimal places, so that's going to be 15, 32.15. Now I'm just going to scroll back up and just do the rest with you, but I'm not going to do every single question, just help you with the labeling. So your hypotenuse is here. This is your adjacent. This is your opposite. This is your adjacent. This is your hypotenuse. This is your opposite. So we're going to be using cos for this one, tan for this one, sine for this one. Okay, so you can go ahead and do the calculations for that. Here we've got the hypotenuse and opposite. And if you want to put theta in, you can. Adjacent, opposite, and adjacent hypotenuse. So for this one, we're using sine. This one we're using tan. This one here we're using cos. So when I look at these, I actually say in my head, so katoa. Okay, so S-O-H, tan, T-O-A, cos, sorry, toa, T-O-A, ka, C-A-H. So katoa. Okay, this one here, this is opposite and adjacent. Here we've got hypotenuse and opposite, and hypotenuse and opposite again. Just make sure that's right. Okay, so we've got tan, sine, and sine. Okay, so you can go ahead and do the calculations for that. It's probably not enough room to do every single one, so perhaps just do another 3 or 4 more. All right, so question 2, same thing. The reason why these questions are here, because in the previous question, our unknowns are always going to be on the numerator. Okay, so notice how we've got x over 31. This one was x over 26. Sorry, I know you can't see my cursor. For this one, we had x over 31, x over 26, x over 58. So your unknown was always in the numerator, which is quite easy because you're like, oh, well, we're just dividing by 31, so the opposite of that is multiplying. In question 2, this is just an example of when your unknown is on the denominator, on the bottom. Okay, so I'm just going to do a few with you. So let's label the first one. So we've got h, your hypotenuse, and here we've got the adjacent side. Yeah, hypotenuse and the opposite. And for this one, here's the opposite and the adjacent. So for the first one, remember, so katoa, you're going to be using cos, sine, and this one's going to be tan. Okay, so let's get going with the first one. So H-O-A theta. What I like about this is it's so routine that you get started and you're like, at least I can write something down, you know. Your hypotenuse is x adjacent 58, so x 58, 42. And I might just double check that I've got the right. Cool. Okay, so we're going to be using cos. So again, write cos theta equals adjacent over hypotenuse. So we've got cos theta. Whoops. Oh, why didn't I write the 2 here? Okay. That blue circle comes up. I don't know whether you can see the blue circle in the recording, but it worries me every time I see it. 42 adjacent is 58 over x. So now, see how your unknown is in your denominator? So you just don't go, you can multiply both sides by x, which is fine. Actually, I might do that. Let's multiply both sides by x. So that cancels out, and I'm left with x cos 42. I might put a multiply sign there so we don't read it as one whole word, equals 58. And then to get x by itself, I divide both sides by cos 42. Okay, because we've got x times, so the opposite of multiplying is dividing, so that cancels. And then we've got x equals 58 over cos 42. And we can just put that into the calculator. So 58 over cos 42. 58 divided by cos 42. Is that 78.05. Now, what I was saying before here, we can skip this whole step in the middle. We can skip all this just by switching. So what we had was cos 42 equals 58 over x. When your unknown is in the denominator on the bottom, you just switch these around. So you're left with x equals 58 over cos 42. So you're effectively just saving yourself a little bit of working out, maybe about a minute. Okay, so you just switch them. Okay, so when your unknown is on the denominator, you just switch. So let's have a look at question B. So where are we? B, HOA theta. Scroll up. So we've got X 2259. Okay, we're not looking at the adjacent side, so I'll just cancel that out. So we're using sine theta equals opposite over hypotenuse. Substitute everything in. Opposite is 22, and your hypotenuse is labelled as X. So we just switch these because X is in your denominator. So we get X equals 22 over sine 59. And plug that into the calculator. So 22 over sine 59. So 25.67. 25.67. All right, and let's just do C just because I labeled the triangle. And it's an example of tan. Okay, so scrolling back up to our triangle just so I can copy down the values. So what have we got? 8x43. So we're not dealing with a hypotenuse. So my ratio is the tan ratio. So tan theta equals opposite over adjacent. Tan 43. Opposite is 8. Adjacent is x. So we just switch these over. So I get x equals 8 over tan 43. So plug that into the calculator. Find my calculator. What was it? 8 tan 43? I think. So no. Did I put that in correctly? Just let me check. Oops. Hey. Oops, I didn't do that right. Not multiply, it was divide, sorry. There we go, 8.58. All right, so you can continue on doing the rest of the questions. There's a lot there and not much space, so maybe just, oh gosh, definitely not much space. So how many? You could probably do 3 or 4 more. All right, question 3 is, I think, a range of questions. Okay, so somewhere your unknown is on the denominator and somewhere your unknown is on the numerator. So I might just quickly go through them. I always say quickly and then I feel like it goes not quickly. Okay, so this one we're using cos. And your unknown is going to be on the numerator. B, we've got hypotenuse and adjacent. So your unknown is going to be on the denominator. Okay, so question A, it's on the numerator. Question B, we're still using cos, but your unknown now is on the denominator. So it's going to be like question 2. C, we've got hypotenuse and opposite. So we're going to be using sine. Now your unknown is going to be on the numerator. So that's like question 1. For D, here's your hypotenuse, opposite. So we're using sine. Now your unknown is on the denominator. So you're similar to question 2. Seems like it's alternating. Let's just keep checking. All right, adjacent. Oh, so this is tan. Your unknown is on the numerator. And F, opposite and adjacent. So that's tan. And your unknown is on your denominator. So I think they alternate. Shall we just keep checking? Hypotenuse, opposite. So we're using sine, unknown on the numerator. Here we've got hypotenuse and adjacent. So that's cos, and your unknown is on the denominator. And then we've got opposite and adjacent. So we're using tan, and your unknown is on the numerator. Okay, so they do alternate between the questions we did in question 1, question 2. So remember, question 1 focused on the unknown on the top of the ratio, on the numerator, and question 2 focused on the denominator. So hopefully you can go through and do them. All right, so question 4, actually I'm just take a drink. Okay, sorry, I probably should have paused. Find the value of theta in each triangle. So in questions 1 to 3, we were finding a side. In question 4, we're going to use the trig ratios to find an angle. Okay, so what we've got here is theta. And we've actually, why do they give us 3 sides? That just makes it hard to choose. Okay, so let's label the triangle. H, O, A. We only need 2 sides. And I also think all of these are, oh, they are. Okay, sorry, I'm just thinking in my head. No, I'm not thinking in my head, I'm thinking aloud. Okay, so let's label our triangle. So we've got 5. Yeah, so this question, they're all examples of what we call Pythagorean triads. So that just means 3 whole numbers that make up a triangle. So you got no decimals, basically, all whole numbers. So if you haven't heard of a Pythagorean triad before, these are all examples of triads. So where each side is a whole number. Okay, so because we know hypotenuse, opposite, and adjacent, we can use any of the trig ratios. So let's go ahead and just do all of them, just to see how it works. So let's do sine first. So sine theta equals opposite over hypotenuse. So sine theta, your opposite side is 3. Your hypotenuse is 5. This time our unknown is the angle. Now, to find the angle, we just do the inverse of both sides. Okay, so that kind of cancels that out, and we're left with theta equals inverse sine of 3 over 5. Okay, so when you're finding an angle, you're using inverse sine or inverse cos or inverse tan. On your calculator, if you're working with the CAS calculator, the button is just here, but we're using sine, and it's 3 over 5. If you're working with a green scientific calculator, I think you would probably just press shift sine, and that will give you inverse sine. So we've got 36.87. I don't know how many decimal places we had to do that to. 36.87 degrees. Let's just go up. Oh, it says to 1 decimal place. Oh, where did you go? So 1 decimal place is 36.9. Now, I could also use, if I wanted to, and I'm going to do it in a different colour, cos. This time cos is adjacent over hypotenuse. So your adjacent side, why did I label it A? Sorry, it should be 4. Okay, so your adjacent side is 4. Your hypotenuse is 5. Okay, so we're going to take cos, inverse cos of both sides. So I'm not going to write that because it just looks like bad maths when I write that. So theta equals inverse cos of 4 over 5. And we'll do that on the calculator. So inverse cos 4 over 5. And you can see, oh wow, we get the same angle. So 36.9, which you would hope we would, because theta hasn't moved. We're still finding this, it's kind of like x. Okay. Do you trust that the next one's going to be the same? So tan theta, opposite over adjacent. So tan theta, opposite side is 3 over 4. So theta equals inverse tan. of 3 over 4. Girls, when you do this question, you don't have to do sine, cos, and tan. You can do any of them. So tan, 3 over 4. And there we go. Surprise, surprise. We got the same answer. 36.9 degrees. Okay, so let's do just another one because we can. Let's do F. Okay, just because I can see it there. Labeling F, hypotenuse, opposite, adjacent. Opposite, hypotenuse, opposite, adjacent, theta. I think my computer's getting glitchy. Let's rub that out. Okay, so your hypotenuse is 29. Opposite is 20, adjacent is 21, and theta is what we're looking for. So we'll call that theta. Now, I'm a big fan of sine. I don't know why. So I'm going to do sine. But you can do cos or you can do tan because we've been given HOA. So let's say we weren't given the adjacent side, I would be forced to use sine. If I wasn't given the hypotenuse side, I would use tan. Okay, but I've been given the opposite and the hypotenuse, so I'm going to use sine. So sine theta equals opposite over hypotenuse. Opposite is 20, hypotenuse is 29. So theta equals inverse sine of 20 over 29. And then we just plug that into the calculator. Now, if you get, I might just show you now, if you get your sides around the wrong way, because your hypotenuse has to be the longer side, this won't work. It'll say undef, which means undefined. You can't do it. So if that happens to you, don't sit there and think your calculator's broken. You've actually made a mistake. So like, oh, yeah, it was supposed to be 20 over 29, not 29 over 20. And there we go, 43.6. All right, so go ahead and do the others. Now you have been given all 3 sides, so you can choose which sides you want. Even if it helps, you can just cross off randomly the sides you don't want to use. It's up to you. I'll leave it to you, but I've shown you sine, cos, and tan. You can do all 3 for each of them. You're going to be there for a while. But the main thing is, girls, you need to know when you're finding an angle, you use the inverse sine, cos, or tan. All right. I think that's a long enough video. I'll catch you later. Bye.